Hey guys, in this video we're going to continue on with our compound inequalities. So first, we know how to graph this, is what we're working on in class today. So the first thing I see here is that the first part of this inequality, it says -3 is less than or equal to x. Now remember, that's the same as x being greater than or equal to -3. So at -3, we're going to have a closed circle, and we know we were going to draw shade to the right. Now we have to be careful when an inequality is set up this way, then we know that it's going to be an and. So because it's an and, we know we're going to shade in between, so we need the other piece first. So that second piece is x is less than or equal to 5. Again, it's got the or equal to, so we have a closed circle in there. And when you have and, we're shading everything in between. So everything in between from -3 to 5 is a solution to our inequality. Now this is what it looks like just set up as using an inequality. But here, you can also use something called interval notation. So in this case, we still are going to go from the smallest it ever was. So our smallest it ever was -3. And we go to our highest possible solution, which was 5. So -3 to 5, everything in between those are solutions to this inequality. But because of our closed circles and our equal tos, they get brackets around them. And let's follow up here in the next one as well. So in the next part, we have -6 is less than x, which is just equivalent to x is greater than -6. I'm just changing the sign because I'm changing the order of the x and the -6. It's a greater than, so it's an open circle at -6. And then we have x is less than 4. So it's an open circle at 4. Again, these two go together. So because it's this single inequality, we're going to shade everything in between. So 3 is a perfect example of something that would fall in the solution set, right? It's less than 4, but it's greater than -6. Everything that satisfies that would fall in here. So again, we're going to put the smaller term, -6 first. Oops. Doesn't really matter what color I use, but you know I like my colors. -6. The greatest it could be is 4, but now this one's different. Instead of getting brackets, I'm going to give it parentheses because those are open circles. These -6 and 4 are what's called not included. So this is included as a solution to the left, part A. And these ones are not included in the solution set because it's telling us that -6, right? X is greater than -6. So -6 is not part of it. 4, same thing. X is less than 4, but not part of it. So one little cheat that we can think of is like when you have brackets, that's for my or equal tos. So you can think of how less than or equal to and greater than or equal to have the line underneath. Think about these being a straight line, okay? And they get a closed circle. But meanwhile, your parentheses, that's for your less than or greater than, okay? They're not equal to. So less than or greater than, and they get the open circle. So the parentheses gets an open circle, okay? They're not included. So then with something like C, you have a little bit of both. So first we have that -4 is less than x. So x is greater than -4. And then x is less than or equal to 8. So I'm going to have my closed circle at 8. I'm going to shade in between again. And this time I'll have a parenthesis on the left, but a bracket on the right. Because on the left, that x is greater than -4. So parentheses go with the greater than or less than. The bracket goes with the or equal to. So we'd be good. Now in D, we don't have a compound inequality because there's only just one. So we know x is greater than or equal to 4. So I'm going to go to 4 and close my circle in. Remember, we can shade to the right because it's all greater than or equal to that. And we're good. So it's going to be a little bit different now when we write the inequality. So we know 4 was included, and 4 is the lowest it can ever be. So I have my bracket in 4, but notice we have an arrow. It's continuing on forever. So something that goes on and on forever goes to infinity. So that's my infinity symbol. It's like a sideways 8. But we can't actually reach infinity. It goes on forever. So since I can't actually land on infinity and have it to the solution to plug in, anything with infinity gets a parenthesis. Okay. Next one here, x is less than 5. So we get an open circle at 5. Anything less than this single inequality is included. So I go to the left and shade in. Now, the arrow is to the left. So the smallest is some number I don't know. It's going to be negative infinity because it goes on and on forever, but towards the negatives of my number line. So we know it's a negative infinity. So we read it left to right. Notice I gave it a parenthesis just like the previous one. We can't actually reach negative infinity, so we leave it as something that's not included. And then we stop at 5, but 5 is less than, so it gets a parenthesis. If it's no equal to, it doesn't get the bracket. Last one here, negative 4 is less than x. So think about things that negative 4 is less than x. Remember, that's the same as x is greater than negative 4. So we have an open circle at negative 4. We're shading to the right. Negative 4 is the furthest to the left, but it's open circle, so it gets a parenthesis. And it doesn't stop. It goes on forever, so positive infinity, but we get a parenthesis on there. So if I go to something like exercise 2 in here, which of the following represents an equivalent interval to negative 12 less than or equal to x less than 4? Well, we know everything should involve negative 12 and 4, right? It's beginning and end. But remember, negative 12 is less than or equal to, so it gets the bracket, less than 4 gets the parenthesis. So we're looking at choice 3. So in exercise 3, we're solving the inequality for all values of x. We're going to graph the solution set and state the solution set in the interval notation. So first I'm going to solve. I'm going to subtract 12 from both sides. We get negative 4x is greater than negative 12. And I'm going to divide both sides by negative 4. Remember, x is less than 3. I divided by a negative. So if I divide by a negative, I switch the sign. Negative 12 divided by a negative 4 is a double negative, so we get 3. Okay. So I'm going to sketch my results now. So I'm going to make my own number line. So I know 0 could be somewhere on here. Put my 3 that I know I'm going to mark on in a second. Maybe I'll put negative 3 on this side too, just for fun here. But when I go to graph it, I know I have an open circle at 3. And I'm shading to the left. So then everything to the left of 3 is in my solution set. So remember that arrow goes on forever to negative infinity. Infinities get the parentheses because they're not included. We stop at 3, but we're less than 3, so it gets a parenthesis. Now the next one, 2 inequalities have solution sets given in interval notation. So the inequality number 1 is negative 3 to 2. Okay, write an interval that represents all the values that are solutions to both inequalities. So given these 2 separate inequalities, I'm going to plot them on a number line first for us. So here's my number line, right? Inequality number 1. Okay, that's -3. The closed circle. And it goes to 2, but that's an open circle. So that's my first inequality. Okay, that's 1. I also have 2 here, but it's an open circle at 0, and it goes to an open circle at 4. So here are my 2 inequalities on the same number line. We want to write an interval that represents all values that are solutions to both. So this is my and. So both have to be satisfied here. So the pink and the blue have to be both satisfied. They overlap in this general area, right? So the overlap for the and to make both of these true is from 0, open circle, and it goes to 2, open circle. Okay, now I know that the pink over here kind of like hovers over, so you kind of would want to think it's included, but remember to satisfy both. If there's open circles for either one of them, like here, the 0 had an open circle. So if I want both to be satisfied, I have to think of it as an open circle, just like for the pink here, thinking that as an open circle. So since they both have the open circles at some point in those spots, it's considered 0 to 2. Now I'm going to do this again. Now the or is nicer, right? It's like anything can satisfy. So I'm going to write an interval that satisfies. So if I look to my left, I'm reading everything in here. So for my or, I have this to start. So we're starting at -3. It's included because it's closed in. But I'm going all the way, like, so everything is included because it's an or. So I go all the way to that -4, but the -4 is not included. I'm sorry, +4, excuse me, +4, but it is not included because it's that open circle. Okay, so or is everything where and is specifically where they both are true. Now, something like exercise number 5, at a hydroelectric plant, pump number 1 is on for all times on the interval from 0 to 8. Pump number 2 is on for all times from 4 to 18. Which of the following represents the times when both pumps are on? So this is kind of like an and where both pumps are on. So again, kind of sketch. I'm going to make my sketch a little rougher here. So I have like 0. I'm just going to hit the big ones here. 4 and 18 for now. And you could make this all pretty and have it all in there. Pump 1. So I'm going to close circle at 0. Oh, and I needed an 8 in there. Open circle at 8. So that's the 1. Pump 2 is everyone in this interval. So close my circle. Over on to 18. So again, we want both pumps to be on. So we want where this overlap happens. So both pumps are open in this case from 4 to 8, right? Because everything's included here, all shaded in, but then there's an open at 8. So we have to think of it as the less than here. One last question to write our solution sets. So we just want to write our solution sets in interval notation again. So just to follow this up here, remember, open circle means parenthesis at -5, and it goes to the right till we're at 3. Closed circle means included, so it gets a bracket. Here we have 2, but we have an or situation, so I'm going to read them all separately. Like I'm going to take this first piece. I have -infinity, because the parenthesis goes with the infinities. It goes until -7, and it's closed circle, so it's included. Or on the other side here, I have an open circle, so I have -3, and it goes until infinity. Okay. Tomorrow we're going to practice that more in class, and we'll go from there. All right, guys, thanks for watching.